Hi, my name is Joseph Patton. I'm a researcher here at the University of Maryland, and we're coming to you from the Proving Ground and Training Center here just off campus. We are looking at the ongoing weather situation today by showing you a little bit of the AWIP stations that we have for use here at our office, and how we can use those to demonstrate some of the lightning imagery that we focus here in our lightning research group here at the University of Maryland. Okay, so starting out with a visible satellite imagery of the entire continental United States, we can see we've got some scattered thunderstorms over the western U.S. stretching into the Central Plains region, as well as some scattered thunderstorms along the Gulf Coast. These are mostly sea breeze type thunderstorms forced by the warm air moving inland from the Gulf of Mexico on shore, whereas these are being forced by a broad trough occurring over the western and into the central U.S. So looking more at that trough, so this is the GFS model from earlier today, and if we go to 18Z, so that's just before now, our green lines are 500 millibar height, so we can see that we've got a deep 500 millibar trough just off the west coast of the United States, and that cyclonic vorticity advection is stretching into the central U.S. And just east of the Rocky Mountains, we've got a little bit of a shortwave mid-level trough as well, and that's enhancing our cyclonic vorticity advection into that Central Plains region. In addition, the image in the background is 1,000 millibar to 500 millibar relative humidity, so we can see that we've got more relative humidity, higher values in this general area of the Central Plains between Kansas, Nebraska, Iowa, and Missouri. So that's going to be associated with a greater chance for convection later today. We've got that warm, moist air that's being fed some mid-level energy by cyclonic vorticity advection. In addition, our mean surface pressure are plotted in the isobars in white. So you can see that we've got a surface low pressure that is situated near central Kansas, and that is going to be providing some surface convergence, which is going to be our initial source of lift for these potential thunderstorms and updrafts later today. So we've got all of our severe ingredients with our low-level support, our mid-level support, our warm, moist air, and then finally our increased surface convergence leading to lift. And then if we take a look using our GO16 mesoscale sector that's centered over this region, we've now zoomed into Nebraska, Kansas, Missouri, Iowa, and I've overlaid with that these blue grids here, or pixels, are flash extent density from the GOES16 or GOES East geostationary lightning mapper, or GLM. And that's basically plotting how many flashes are occurring in 1 5-minute window associated with that particular pixel. So we can see that we've got some ongoing thunderstorms already over western Kansas, and then especially there's a complex of storms that had been going on for several hours over Illinois, but that's not going to be our main severe threat today. Our main severe weather threat is going to be associated with these storms here. We can see that we've already got a healthy low-level cumulus field streaming upward into western and northern Kansas, and that typically means that you've got the warm, moist air ready to be utilized for convection later in the day. And then finally, just to demonstrate one of the things that we look at more often here, we really focus on lightning here in this proving ground, and to show you a little bit about how we can use those GLM products to better understand ongoing thunderstorm activity. We've plotted the three main GLM products. Flash extent density, the one you just saw, is up in the top left, so that's their the number of flash counts. Minimum flash area is in the top right, so that's the size of the smallest flashes, and those smallest flashes usually indicate your strongest convection or your core of your updrafts. And the total optical energy is in the bottom left, and that's essentially just how bright are those flashes. And finally, for comparison, we have the GOES 16 full disk channel 13 long wave IR here in the bottom right. So what this allows you to do is you can easily pick out which storms are your strongest ones by looking for where you've got high flash density, such as in the far northwest portion of the Florida Panhandle. And you've got your strengthening storms are probably going to be associated with low minimum flash area, so your gold pixels. So again, those storms in the far western portion of this Florida Panhandle stick out. And then you can verify that with your brightest flashes on TOE. And again, those storms in the far western portion of the Florida Panhandle stick out. And if you compare that to what you can see on the channel 13 GOES imagery, you can see those are coldest cloud tops as well, with those orange and gold pixels. So that's one way you can use the products from the GLM to better understand the convective activity and what your severe threats may be and which storms you may need to focus on in an operational environment.